All right, let's look at the complex exponential function with complex bases. All right, so let's say a and b are both complex numbers. Then what would be a to the bth power? All right, so let's look at that. All right, so a is a base, but since we don't like it, so I'm gonna rewrite a as e to the natural log of a. Right, so that will be exactly the same thing as a. Then we have to raise this guy to bth power. Right, so we can write it as e to the b times natural log of a. Right, so that's what a to the b should be, right? All right, so let's use that to try to understand I to the I, right? So what kind of value is I raise it to the ith power, right? So following this definition here, so we have I is e to the natural log of I. Then you raise the whole thing to I, so you're going to have I here, right? Then we know how to find the natural log of I, so you have e to the I, right? Natural log of I would be natural log of r, which is the absolute value of I, which is going to be 1, plus I times, I'm going to change the parentheses to bracket here, angle of I. So again, I is going to look like this. You don't have to do this every time, but sometimes I have to do it. So you have here, and I would be right here, so it's going to be 1 here. So this is our I right there. So we want to find the angle, but this angle is going to be pi over 2. Then you would have to have plus 2n pi. So this is pi over 2 plus 2n pi. All right, but we know that natural log of 1 is 0, so that goes away. Then I'm going to distribute this I to an I, so I squared would be -1. So therefore, we get e to the negative pi over 2 plus 2n pi, and where n is any integer, right? So that's the value of I to the I, right? Interesting thing is you notice that e to the negative pi over 2 plus 2n pi is a real number. So I to the I is actually a real number, right? That's it. I hope that this was clear.